Before the Damascus can be created, the 15N20 and 1084 billet must be cleaned to ensure good weld fusion in the forge. We remove the mill scale on the belt sander, then wipe them with acetone before TIG tacking with no filler wire. Once the billets are tacked, they are preheated in front of the forge till the borax melts. After the billet soaks to a white heat, the weld is set by hand before we move to the power hammer. Safety is our first priority. Never wear multiple nylon clothing while forging, and protect your eyes, ears, and hands with appropriate equipment.
The billet must be drawn out to several feet in length before it can be cut, ground, and restacked with the same care the initial stack was made with.
After we make the secondary stack, we rinse and repeat the forging process before we can draw the final bar out into a sword. This time, instead of cutting and cleaning the long bar, we get our first peek at the sword's final form. A rough taper, profile, and tang are forged into the sword with the power hammer, and the finer details are worked out by hand. Now that the blink is formed, it's time to start grinding. Flat reference surfaces are set on the base of the blade with a surface grinder so it can be clamped in a mill securely. Most of the work is done by hand on the belt sander. Always wear eye, ear, and respiratory protection when grinding, and remember, if it spins, don't wear gloves. The blade is flatted before the center line is marked so the beveling can begin. Beveling was done completely by hand without jigs or grinding aids. After the bevels were set, we hand filed the whole sword to make sure they were flat and perfectly true. After we file the blade, we do an initial etch and finally get to see our pattern. Here, the investment shelled molds for guards are put in an oven to melt out the wax. We spent a lot of time modeling, 3D printing, and handcrafting molds like these out of wax, but ultimately none of the guards came out. The investment shells were preheated to 400 degrees Celsius and set in green sand to support them and catch spills. We used lost foam and green sand to make the pommels. All of the molds were cast from scrap bronze, and we think that bad metal may have played a role in the poor casting quality. Others simply did not fill. Though we were disappointed in our results here, we learned quite a lot about investment casting and hope to apply that to future work. Since none of the cast guards worked, we decided that it would be best to forge pieces of a guard and TIG weld them together, rather than change our original design to something easier to create with traditional technique. Once the pieces were together, we forged the final shape. Here the pieces start to come together. The African blackwood handle is burned out to match the tang of the sword. The guard is fitted up, and the handle is turned down to accept 1032 thread for the pommel. The entire sword was clamped in a 4-jaw lathe to ensure a round, centered, and very strong rat tail for threading. The interrupted cut was taken very slowly and delicately. Once we are sure the pieces will fit together, we can move on to the last truly stressful part, heat treat. Since there was no furnace big enough to hold the sword, we had to work it back and forth through our propane forge. Heating the blade evenly was very difficult because of the tapered shape, and the fact that the forge did not fully contain the sword. We tested the blade with a magnet and judged the color of the steel by eye before quenching in motor oil. Here you see the first quench. The blade came out of this quench slightly warped, so we decided to try again. We did a quick process anneal and then a second quench. The process was the same, but with practice the blade came out much straighter, though some warp remained. The blade was tempered at 200 degrees Celsius for an hour and a half, and came out with a deep purple color that showed the pattern of the Damascus.
A fine scabbard was made with a wood core and leather wrap with handmade belt and buckles. Once the blade is etched and polished, we finally finished our sword. As a team, we're proud of what we've accomplished, but couldn't have done it without the help we've had both from inside and outside the materials science department, and would like to thank everyone who has had a hand in this project.